Welcome to Brain Vision.
We begin this question by calculating the acceleration of gravity on the surface of this neutron star. So, on the surface of that neutron star, the acceleration of gravity is given by the Newton constant times the mass of the star divided by the radius squared of that star. If we forgot, the Newton constant is equals to 6.67 times 10 to minus 11 newtons meters squared kilograms squared. Then, on the surface of that star, the acceleration of gravity is equals to 6.67 times 10 to minus 11 times 2 times 10 to the 30 divided by the radius squared. So 5 times 10 to the third squared. Okay, what do we do with that? Well, let us approximate it. This gives us a surface gravitational acceleration of approximately 5.3 times 10 to the 12 meters per second squared. Note that it's way bigger than the gravity on the surface of the Earth. This is because neutron stars are super dense stars, so they have huge gravitational acceleration. Now, we proceed to calculate what is the acceleration of this object that is falling on the surface of that star. So, there is some object falling. Therefore, there is a weight force pulling it down. That weight force is given by the mass of the object times the acceleration of gravity on the surface of that star. So, the weight force is equals to the mass of the object times 5.3 times 10 to the 12. On the other hand, according to Newton's second law, the net force acting on that object is equals to the object's mass times the object acceleration. So, the net force is composed only by the weight force. Therefore, the mass of the object times 5.3 times 10 to the 12 is equals to the mass of the object times the acceleration. Therefore, the acceleration of this object is equals to 5.3 times 10 to the 12. Now, we proceed to calculate what is the velocity of this object after falling 0.01 meters towards the surface of the planet. First, let me organize the board. Okay, now to calculate the final velocity, we will use Torricelli's equation, which says the following. The final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. So, in this situation, the initial velocity is equal to 0, and the displacement is actually a displacement in the height. So, the final velocity squared is equal to 2 times the acceleration of 5.3 times 10 to the 12 times 0.01. Now, taking the square root, we get a final velocity that is equal to the square root of 2 times 5.3 times 10 to the 12 times 10 to the minus 2. And this gives us a velocity of approximately 3.3 times 10 to the 5th meters per second.